you know, it's stuff, like I said, everyday stuff to fit in the activities of the day then, right? The market, today's Sunday, the cooking, it's stuff. It's never easy, and I think that's life. It's never easy to get 60 push-ups in. It's never easy to get, a class in. It's never easy, but that's life, right? Like, yeah, you ever ask yourself, what's the alternative? Is the alternative really lying on your bed whole day watching Netflix? That may be okay for one day, but every day or every Sunday, it can't be, right? I think eventually you'll get bored, or you should get bored, right? It's relaxing, yes, but it can't be every day, right? It can't be every hour of the day, right? You can do that. I would probably do that, but not now, probably later on tonight if I can't find anything to do. But I'll normally find something else to do, right? Find some project or something to look at or something, right? But fit in your studies then, right? And every day, as difficult as today may be, as it is a Sunday as well, right? So we are on 1.3 for those who were here on Wednesday. I did say the video was uploaded already. We are still on outlining main risk management techniques using the oil and gas industry. Can you see the syllabus in the background? Yeah. Yes, okay, good. 1.4, explain the purpose and content of an organization documented evidence to provide a convincing and valid argument that a system is adequately safe in the oil and gas industry. Now, I would want to reach there today, but I mean, we may barely touch that today. I don't know if we're going to get to 1.4 today because I did say the risk management techniques is kind of long now. If you watch the syllabus here, right? The concept of risk control using barrier models, right? And so this is the piece that we are on. We have covered hazards. We're going to look at the bow tie and stuff here as well now. So this is just one line, but the work in 1.3 is a bit long. Like these here may be 1.4, maybe all of these lines here, but it's not long. Like this is just a readout. Look at right here. This is not hard. This will take us like 10 minutes to do. Whereas this point here, the concept of hazard realization takes a bit longer because there are many techniques involved in that then, right? So let's gonna go back to the PowerPoint from Wednesday. Um, so I have it on documented evidence there, but I know we're not gonna reach that far, right? So we had covered in detail the hazard on Wednesday. Let's just look at another one. This one, anyway, I'll just read it, right? I don't know how much, details to go into it. Let me read a couple of slides, but I know they like this. I know they like bow tie analysis. I know they like that a lot. They love this, in fact, right? ETAs, right? FMEAs, not too much, right? And that'll kind of wrap it up there for the techniques, right? So I'll kind of, that doesn't mean too that you won't study hazard. It's just that the past papers have more been on bow tie and stuff then, and Swiss cheese and hazards rather than hazards, right? So a hazard study, which is essentially a structured brainstorming technique, is carried out by a team of competent personnel from a mix of disciplines and led by a person who is experienced in the hazard technique. Each area of the installation is considered against a checklist of hazards, where it is agreed that a hazard exists in a particular area. The risk presented by the hazard is considered, and all possible means of either eliminating the hazard controlling the risk and or the necessity for further studies are noted in a hazard worksheet. I'll explain in the end. So this is something we got from, one of our counterparts. Hazard process, assemble workshop team. This is not a learner, this is just for explanation. Use hazard checklist to identify potential HSE hazards. Use risk assessment matrix to assess the risk. Identify all major accident hazards, assess all major accident hazards, etc. Right? So there's no need to learn this. I still want to read one more, then I'll stop. So there are some similarities between hazards and hazards, as you can see if you represent it as a Venn diagram. Both of them, they are a structured review of health and safety risk for an operation activity or project. It's a bit different. A hazard uses a checklist approach, whereas HAZOP uses like the guide words, like more, less, reverse. Hazards could actually use process and instrumentation diagrams or PNIDs. Hazards, sorry, does not require process and instrumentation diagrams. HAZOPs do. Again, there have not really been any questions like that. This is just something, by analysis anyway. All right. So let's try to explain what the hazards are. So the hazards, in a sense, is a checklist, right? If you see it here, has a checklist. A hazard is essentially a structured brainstorming technique carried out by a team of competent personnel, right? Each year of the installation is considered against a checklist, right? So, like a hazard is more of a, but I mean, both they say a brainstorming anyway, but with the hazard, there's like a prefabricated checklist, right? So, like, just we could probably picture, trying to see how best to show you this, like you can picture like a checklist for like a work area where you have a forklift, they would have in it the forklift. And the checklist would have in it, like condition of the forklift, good, bad, fair. So a hazard is like that. It's like a prefab checklist if you're looking at valves, right? And so it's a bit different from a hazard approach. So the condition of the valves then would be there just for you to check off, right? A hazard is a checklist approach. So the first one may be good, the other one may be bad, the other one may be well, not maybe bad, maybe signs of deterioration, then bad, then replace, right? But it's a checklist, right? So condition of maybe a sensor, right? On a tank, right? And so it is hazard identification, right? And once you tick yes, then they will go and do a risk assessment that, like on that particular hazard, right? So it's not a hazard at all, right? It's really a prefab paper that the operator will go around with. I put in more equipment here, right? But I suppose you could probably put the condition of the work area, right? If it's a platform, housekeeping, right? And it doesn't just have to be equipment. And so housekeeping, they just use like on that morning then, right? Like, you get a sheet of paper and you do your walk around, and whatever you see, you sort of take off, and that's the hazard approach, right? Of course, it can get very detailed, tank condition or whatever, signs of overflow, yes, no, right? Within specification. So definitely see if you see the difference. The hazard had like a defined heading, right? Guide words, possible deviation, um, consequences, right? GDPCA, consequences and action plan, right? But the hazard is a bit different. It's like you check, and if the conditions of the valve is good, but then you put good, sensors are all good. Housekeeping probably need a bit more. Tank conditions, good, right? But if something did turn out to be bad here, then a risk assessment will follow, right? If you read this line here, where it is agreed that a hazard exists in a particular area, the risk presented by the hazard is considered, and all possible means of either eliminating the hazard or controlling the risk and or the necessity for further controls are noted on the hazard worksheet, right? So I'm not going to overdo it. I think that's actually overdoing it there, but I did it like this so you'll understand what the words were trying to say, right? And for me, I kind of remember a question on hazard, right? But that doesn't mean that there would be one, right? For now, though, there are no past papers that I could think of on hazards anyway, right? So I'll choose and move on here, right? You'll have a read of it. Like I said, the PowerPoints are very sufficient for you. They should be your foundational study material because they're written to point to the syllabus as opposed to reading a whole passage or trying to figure out what they're trying to say. This is the purpose in creating PowerPoints, right? So that you have what you need to have and you have what you need to have for the exam. Right? Let me I was admitting some people again there, so let me see, make sure everybody is in. Right? So let's go to bow tie. This is very popular. Um, I'll read a couple and then I would explain a couple as well, right? So the bow tie method is a risk evaluation method that can be used to analyze and demonstrate causal relationship in high-risk scenarios. The method takes its name from the shape of the diagram that you create, which looks like a man's bow tie or a bow tie. The bow tie gives a visual summary of all plausible accident scenarios that could exist around a certain hazard. Second, by identifying control measures, the bow tie displays what a company does to control those scenarios. The left-hand side of the bow tie describes how events and circumstances can release a hazard, which, dependent upon the effectiveness of the systems and activities in place, called active control barriers, can lead to an undesired event or the top event with the potential for harm to people, asset, or the environment. The right-hand side represents the scenario that may develop from the undesired event, the consequences, dependent upon the effectiveness of the system and activities, reactive control barriers. The bow tie have the advantage of being a clear graphical representation of what can sometimes be complex, a complex safety system. They show clear links in safety management systems. Active barriers are put in place to prevent hazards from causing the top event. I'll explain that in a bit. The reactive barriers put in place to reduce the consequences. Each barrier relies on one or more activities carried out by the organization, such as design, engineering, or operation to ensure its presence and effectiveness. Barriers can be hard, such as fire explosion wall design, or soft, such as procedures and individual competence. So if you want, let's start one from scratch, right? I'll walk you through one from scratch. You just have to have some paper around. I could fit mine right up there anyway, right? I'll explain it as we go along. So if you want to start, just start at me. Remember, I told you all this. I cannot see why anybody will come to our class and not have writing materials, right? So you start off and the center of it, whatever you want to draw it as a circle, an oval, whatever, right? That's where you put the thing you're trying to prevent. So that's called the top event. So if we just say fire, we could say more, right? I mean, if we could say chemical spill something, but I suppose to appeal to the masses, then we can just go with something very common, right? We could talk about corrosion and stuff you're trying to prevent, but I think something like fire, anybody could understand that, right? So what you put in the middle there is called the top event. You could take a note of that, but it's in the slide, and so all you have to do is just read over your slide. Right? And what you do, well, from what you read, it seemed to be the bow tie have a left-hand side and a right-hand side. You can just draw a line like this. It doesn't have to be perfect like mine. I mean, mine is not perfect, but it doesn't have to be, right? You just draw a line like that. And what that creates, it creates a straight line, huh? This kind of end up with a curve. It creates the idea of a left-hand side and a right-hand side then, right? So draw another one. And if you notice, well, here then, if you connect the dots here, you kind of get that bow tie thing going on there, right? So we just do two, and I'll tell you what I mean by two, because you could put more lines. You can see if you look, you see three, right? You could put four, but I mean, so simplicity's sake, we can just do two so that the diagram here doesn't look too congested, right? So we end up with what is called like a left-hand side and a right-hand side. Left-hand side, right-hand side. Now, this method is very important. Just remember that this is actually what is referred to as one of those barrier models. You see why they call it a barrier model just now. We're still trying to set it up, right? So bow tie has a left-hand side, it has a right-hand side. Then when you finish that a bit, let me know when you finish this. I want to be wasting too much of time. If you kind of drop it out already, just let me know.
Finish.
Okay, cool, right? All right. So just if you can listen to this, I'll write it on the slide for you just now. In fact, it's there already, but the eyes have to be open to it now, right? So on the left-hand side, right? The left-hand side of a bow tie analysis, they say it's proactive. right? It's proactive, right? So why it's proactive, right? On the left-hand side represents everything you're trying to do to prevent a fire, right? So a bow tie is proactive, but on the right-hand side, it's reactive. What does that mean? On the right-hand side, what they do, they consider what if we have a fire? How would we survive or recover from it? Think you understand that? Let me say it again. A bow tie have the advantage of being like before an accident. You can consider what happens before an accident or a fire. But on the right hand side, they consider like what is our contingency plan? What if the building did go up in smoke then? Right? So you understand that? Like a bow tie, I'll say the word again, a bow tie is preventative. So if you look here, you're gonna see threats. You see threats, threats, threats. Threats mean like it didn't happen yet, but it's just a threat now. So on the left-hand side, they consider like what could cause a fire. If you want, I could use another word. I could use causes here, right? All of these are acceptable words, right? Remember, there are different NEBOSS causes, sorry. So on the left-hand side, they consider like the causes of a fire. That's supposed to be CAUSES. Forgive the marker, right? Zoom marker is not the best because you really are just because we really have to, sorry, you have to kind of um trace on the notepad now, right? It's not as if we actually press in the letter C. We actually have to, like when you go to some places, you like you sign your name on a notepad. So Zoom is like that. You have to trace on the notepad then, on the cursor then, right? So on the left hand side is the causes. So if you say it's the causes, what they're trying to say is that it didn't really have a fire. They just consider like what could cause the fire. So on the left hand side, this is said to be proactive. So you can take a note of that. The left hand side is proactive. It's like you're being proactive because you're considering what could cause a fire and you're trying to stop it, right? So the left hand side of a bow tie is proactive, right? However, what I'm saying is that in business planning, then it's a good plan to consider, well, how do we survive if this goes wrong? How do we survive if we have lost our office? Is there a contingency plan? So if you watch here, you see the consequences, lawsuits. Like whatever they were talking about, this is contaminated drugs, right? So like they have a plan for a lawsuit. A plan for a lawsuit may be having a good insurance scheme or having a good lawyer, right? So on this side, it is said to be reactive. However, I don't have space to write the words. I'm going to write it. I don't know if you could write it because I have threats, threats, threats there, right? I could probably write it up here. The right-hand side of a bow tie is reactive. You're considering what if this thing happens, right? But how do you survive then with a fire, right? So let's take a look at two now. We can only look at two because there's only two lines we draw. So we can look at two causes of fires. I'll give you one, and I want you to give me one. So I'll make up a tough one. I'll leave the easy one for you all, right? I think it's easy. So the causes of fire, we can say this is in a company. I can say probably a chemical spill, right? So I'll put here the causes of the fire is a chemical spill, flammable chemical spill that sort of met an ignition source, right? So chemical spill. Give me a minute to admit somebody again. So give me another cause of a fire.
How about a tripwire?
Okay. So some electrical fault. Give me another minute to admit another student, right? So I'll put here electrical fault, electrical, right? Cause of a fire, electrical. Right? And so if you understand a bow tie, anybody could actually do it. It's a very simple diagram. I mean, we just drew a circle, didn't we? We just drew two lines around that circle, right? However, like once you do that, you start to see a left hand, like you see two sides on the left hand side and the right hand side. The left hand side consider all of your causes. If you want, you could block this off so that you understand this is like a bigger category, causes, right? Now, watch carefully now, right? 'Cause this is what NEBOSS, like they refer to this as a barrier control model. When we finish, it have a paper right here. And it from Wednesday, I showed you a paper too, right? There's like discuss a barrier control model. If they say discuss a barrier, I would expect you to talk about the bow tie, right? But it's how would you say it in words? Now, I have it on my slide. You can memorize it, or you could try to internalize part of it, right? But anyway, once you do this, so why is this called a barrier model? Watch it carefully now, right? What they say is that along this line, if nothing is done, well, then we would have a fire. But if we put in controls here, the controls would actually serve as a barrier to the chemical spill. So therefore, this model is actually called a barrier model, right? So the more of them you put, if you watch, you see threat barriers. Watch carefully now. Threat barriers. Now you could draw them like that, but I would draw them individually to show that it could have more than one barrier then. A barrier then is like a control, right? So we draw them like this. I'll draw three, make sure they fit in three, right? Each one of these along the line would actually prevent a chemical spill. So if these are all barriers to the chemical spill, if these barriers work then you would not have a fire. So what could be these barriers, right? If you want, let me give you one and then you see if you can give me one. The barriers are the control. So how do you prevent a chemical spill? I suppose maybe with a sensor on a tank, right? Or whatever, I'm just kind of thinking about a tank there, right? So a sensor on a tank and a shutoff valve, right? So with the sensor, I didn't think you could write it, if your diagram was bigger than mine, you could actually write sensor slash shutoff valve. A shutoff valve is like the valve in your water tank at home, or at least you should have like okay, like the float then. When the tank reaches a certain level, the tank should shut off for itself, right? Of course, in the company, in the industries and stuff, they'll have a sensor that will probably trigger the shutoff valve and then the valve will close, right? So with the sensor and the shutoff valve, you wouldn't have a chemical spill, right? I suppose another control could probably be things like trying to see what because I do some of this in the company. If anybody does it as well, maybe they could tell me. And some of y'all work around tanks as well. I have Cohen, I have Steven, right? But for when I did it, I like they would have certain shifts, gauges as they call them. So I'm trying to put that into a barrier, though, like what would we call that as? Like maybe proper supervision. So could I write it to the top here, right? So proper supervision of those tanks. And if the proper supervision was done, like a gauge is required to come by every 4 hours, right? And like they would check the fluid level, they would ascend the tank. There's like a dipstick. They will go on the tank, they will take a measurement, and then they would record that on a sheet, right? So proper supervision is a barrier for the chemicals, but if it's done in that way, right? Could you think of another one? Or maybe I maybe put in a hard one there for you. But anybody could think, how do you prevent a spill again, a chemical from spilling? Let me see, somebody put it in the chat. Okay, routine monitoring of fluid levels. I think that may be the same thing as the gauger rod, unless Cohen, if there's another way.
I don't know if I missed this one because I just logged back in. Is it I believe because I'm not exposed to that, but it has tanks similar to the toilet tank with the floats. I believe that's also a trigger. I'm not sure.
Yeah, it is. I may have mentioned it here under the sensor, just I didn't write it because I could write it and I just didn't have space. It's called like a shutoff valve. Uh, Rousseau shut-off valve. SOV, shut-off valve, right? Some companies call it a ROSOV, right? But a shut-off valve, SOV, shut-off valve, right? So that's perfectly correct there, Alicia, as well. But I wanted to write it here. I just said I didn't write it. I'd ask the class to write it. Anybody else? I thinking so they prevented, not a bond. A bond is not preventative. A bond is more reactive, like having a spill bond then, right? So this is all about good tank management, good supervision, making sure the sensors and stuff working, right? Maybe I could probably think something as some code from code. I could probably put in maybe some monitoring of the flow rate, right? All of those things, those of us who do gauging tanks and stuff, the flow rate, all of those things are kind of calibrated. Like the gauges would actually know like the flow rate, into the tank per minute and stuff like that, right? This ended up being a hard example. I thought it would have been an easy one, but maybe I chose chemical spills and that would have been the hard one, right? But the point is though, if the barriers work, then it wouldn't have a chemical spill. Think you understand that one? So if the barriers work, because the barriers, if you see the barriers prevent, then the barriers prevent the chemical, right? Once the barriers work, you would not have a fire. Therefore, on the left-hand side, these controls then are really proactive. Think you understand that a bit? All right. For electrical, I would just show them. I wouldn't write them. I would say probably for electrical, maybe we could have good maintenance. So a barrier, I'll just draw one line because it will look very complicated if I draw all of it. A barrier can be proper maintenance, right, of the electrical equipment. Another barrier could be proper inspection of electrical equipment. What again for electrical? Possibly there's something in England called portable appliance tested. I don't know if that may be applicable here, but some sort of inspection maintenance, would be if these barriers work, the electrical components are properly inspected, maintained. If they have suitable design, maybe one of these things could be that they would have been good components, proper design. I don't know if you want to write it out. I'll say it again. Maintenance, inspection, design. This is only for this example. But I think those could work for anything, eh? Because those are some big categories of answers. Maintenance, inspection, design. Then the electrical components then should be good and it should never have led to a fire, right? So that's the idea for bow tie. Just remember the barriers here is what makes it, sort of good. With the barriers, you kind of prevent the electrical from causing a fire. I draw this one skinnier. That doesn't mean it is. It's just to kind of make it fit, right? On the right-hand side though, right, Cohen have using the correct rated materials, right? But if you know about that electrical work, something called D rating, right? Using the proper rating. So you don't use like the higher rating, right? This is a whole thing by itself. So I want to explain it, right? Just know that there's something where you use, if something is a 110 voltage maximum capacity, you use something less than that. If you could use a piece of equipment that uses less power, or you use a fuse or what is called a step-down transformers, all of those things could be applicable here. The whole concept of derating could apply there, right? Anyway, on the right-hand side, we consider what if we have a fire? How do we deal with it then, right? So the consequences of the fire, you see this here, they have lawsuits. So the consequences could actually be, yes, civil action, right? Maybe some employee was damaged. How do you deal with it? So on this side, you are now coming up with then like a contingency plan, right? Let's say property damage, I'll just put damage there. How do you deal with the consequences of a fire, right? So I'll just do this one for you all. So the more the more of the lines you have again, though, the more of these you have, the more barriers you will have. And the more barriers you have now, it's not as if you'll be preventing the fire now, the fire happened already, but you'll be minimizing the consequences to your company then, right? So the company could keep on going even if it have a fire. So in terms of a lawsuit, I was saying maybe one of the things you could have is insurance. Yes, workman compensation covers those things. If you could write it out, write out the whole word for me, right? RANCE, insurance. Yes, I'll say it again. Workman compensation covers those things. If somebody sue your company and you have workman compensation, the insurance comes from not your pocket, but it comes from the insurance, right? That's one barrier. Let me give another one. Another control over civil action, because the consequences here is civil action, right? I suppose, I mean, then insurance. That's a tough to come up with another one. Insurance is just as good. Like, how is you save yourself against civil insurance or civil actions then? Right? Well, I thought of another one. I don't know if you'll understand it, but you could have what is called but they call it retention at the degree level. But retention is where the company have money put away then for a case like that, where it mightn't really be from insurance, but they have a fund set up to deal with civil actions, right? They have like a fund, FUND, right? They have a fund set up. So hopefully your diagram is much bigger than mine, right? And you could fit in those things, right? So you have a fund set up for like recovering then from civil action, right? Um, I can't think of another one, right? Civil action means somebody is suing your company. I guess you could have a team of lawyers, right? If you retain like a good lawyer, good law here, right? If you have a good lawyer, then or you and the top lawyers in the countries are good. Those of us in Trinidad here, you have Anand Ram Logan or you have um Michaela Pandey, you know. But you're sure to win then, even if somebody's suing you. Well, probably you wouldn't win, but maybe the amount that is settled would be less, right? So that's a contingency plan. A contingency plan is that, and companies do have it. I mean, there are companies that have a legal department. If you all know, there are companies that have a legal department that deals with that, right? So you have a team of lawyers, we have insurance, we have a fund, something called risk retention. That's the proper name, risk retention, where the company has a fund set up where, some money is going out every month in the event of somebody being injured or worse yet, suing your company. You have a fund set up for that, right? So the damage to equipment here, what you could have again is insurance. I'll just draw one line. You'd have insurance. You could probably have maybe you could have like some companies may have like they'll have an off-site office, right? So in case their office is damaged, they could have like an off-site area that they could run from. Maybe you have I'm actually looking into this right now, something like a data server where even if your office was on fire, the workers, once you have internet and stuff, you can actually access all company records on a data server. And that may be remotely stored on a cloud storage system somewhere, right? So that's a way in the event of fire in your company could still survive, right? You have insurance. So yes, the office may have been burnt, but you're gonna get money because you have insurance, right? It will take some time for investigation and thing, and it may take a year and more to kind of depends on how approvals go. But if it's your building, I think it could start working once you get the paperwork cleared, right? You'd have to go through talk and control, unless if you do know over another building, right? And like a means of saving your data is to have some sort of a server, some sort of cloud storage somewhere where in the event of a property damage, that yes, those equipment, that those computers, those servers may have been burned and destroyed, but at least you have it backed up on some sort of cloud storage, right? So do you all understand if you just kind of step back from the chat a bit, do you all understand? Let's kind of look at it a bit in a different light, which is a big overview, which is a bow tie is very good because it helps you to prevent something bad from happening. But if it does happen, you have a contingency plan in place. Tell me if you understand that part of it anyway. And then the barriers, the more of those lines you draw. I've drawn three. I've drawn three. That doesn't mean it have to have three. It could have five, right? The more of this you put, the more you will control then that negative event. If it's a damage or somebody suing your company, the more of these things you put, the more you control it or the more you mitigate. If it should happen, that you will still be able to survive and business will continue despite the negative event, right? What do you all think about that? What, what, I was just thinking how many of us, and it's just such a good model, right? Like how many of us have one of this for our own lives, you know? Yeah, you ever thought about that? Maybe after class, not now I say it, right? Like how many you have have a thought of this? Like what do you do? Do you have a contingency plan for your job? Do you have a contingency? And I mean, I'm not saying that you have it now, right? One of the lessons I've learned in life is everything takes time now, right? Many years ago, yes, this is another story. Many years ago, I remember working for another school, um, and they were not paying us on time, right? And so it was kind of alarming because lecturers were not being paid on time. It happens a lot for tertiary schools, apparently. But it was new to me because I was accustomed being paid on time, right? And I remember mentioning it to a lecturer, a fellow lecturer, and he told me he passed on now. He passed away now. He told me that put a plan in place, right? Put a plan in place because like start putting some things in place now. And that's when I like for those who know me, I never really decided. It never dawned on me then to become a NEBOSS provider. That was never anything I wanted to do. I mean, never. It never was, right? But it's because of that I started to realize, well, what if I do this? What if I do that? What if I go to England? Right? And that was just the plans now. It didn't happen yet because I was still sitting there at the company. I was still not being paid for that month. But the idea started to kind of be there then that like I could have, like approached NEBOSH for accreditation, right? And that was something I never really like studying and working. That was not my plan anyway, right? So I was saying for you too, like I mean, and for me too, because I sometimes talk to myself in these classes too, that like a bow tie is a nice way to think about what you have now on the left hand side, like what you have, around you now. But what if that doesn't work out? What contingency plans you have in place for your job, what contingency plans you have for later on in your life, right? Like a bow tie is a good way to think about that. And a lot of people do it. A lot of people, I've known people that go and study new disciplines, because they wanted to. Some people say, look, I'm going to retire soon, but I can still lecture. So I've known a lot of people who went and do their masters and stuff because of that, right? You kind of put things in place now, right? And I'm sure you all do. I'm sure you all have some sort of savings somewhere, right? You kind of put a bit of savings somewhere for later on in life. Maybe you have a life insurance kind of policy, all of those things that is like a contingency plan. Because remember, right? Like we're not getting younger, are we? I mean, strange, right? Like we're not getting younger, Stephen, right? Day by day, every day that goes by, years go by so fast, right? The pandemic was now, what, 5 years ago, right? 2020, the year that everybody sort of dreaded. That was like 5 years ago now, right? 5, 6 years ago. So years go by, and maybe, I mean, yeah, we're talking about safety, but some of these things can be for everyday life. Put some things in place. Those who know me, I'm putting things in place, right? Those of us who know, I've mentioned this to all my classes. It's not a secret, hence the reason I mention it. And it's also because that's the kind of person I am. I teach, but I think part of being like a trainer, you can never train unless you have gone through it now, right? Like you can never talk to somebody about this unless you go through it yourself, right? So like those who know, Stephen knows, a lot of my degree students know, we have started work on our building, a new building in San Fernando, right? And it's all part of that grand contingency plan, of preparing for the future and stuff, right? So maybe in 2 years' time, because I'm trying to do as much as I could, right? And maybe in a year and a half time, we will have our new building in San Fernando, Palmis, and you will come by and do a course there with us, right? But I mean, this for those who are here, you remember what we said, that these were the days when it was just in the planning stages. These are the days when it's just in the dirt stages then, right? The grass and the dirt stages anyway. All right. So think about yourself. Think about maybe those of us who have kids, those of us who want to have kids, all about that. A bow tie is a good way of I'm not saying that you're gonna draw one, but it is reflective of everyday life as well, where you like you see what you have now, but then what you could have, in plans in the future to prevent, the future that is of course readily approaching anyway. All right, take a look at that. It would have been nice if we could have stopped now and look at the question, but I don't want to, right? Let's move on to another one, right? I'll move on to another technique. We have two more techniques to wrap up, right? So this too, I think, is very popular because of NEBOSS and the idea with the barrier model, right? We mentioned this one on Wednesday. This is something called an inventory, ETA. Let me read the slides with it too, and I'll come back and do a brief explanation. FMEA is not very famous. I may just read out that one, and then we can probably look at a question if there's anything, right? So ETA stands for inventory analysis. ETA is based on binary logic, which from Wednesday we mentioned that uses, I'm not sure if you all did that one with me, but binary logic means it uses numbers of zeros and ones. If you want, I could write it for you, right? Binary logic uses zeros and ones. And there is a whole of numbers between the number zero and the number one, right? So zeros and ones. If you look at the movie Matrix, the start of the movie Matrix have, if you look at the screen, you're going to see a lot of zeros and a lot of ones, right? A lot of zeros and a lot of ones coming on the screen. So that's binary, right? And what I was saying, the ETAs, they calculate like how something could fail then down to a decimal point. So like they will calculate how something could fail down to 0.00. As I mentioned, there's a whole of numbers between 0 and 1, right? So they could, an ETA calculation would actually calculate the risk of an explosion down to 0.0089. And that's just an example. That's not really what it would calculate it to other numbers as well. I just given an example of what binary logic means. 0.0089 is a number that exists between 0 and 1, right? Again, there's a world of numbers. There's a universe of numbers then between zeros and ones, right? Um, Inventory analysis provides an inductive approach to reliability assessment as they are constructed using forward logic. ETA is a graphical representation of the logic model. I'll show you what that means just now, and identifies and quantifies the possible outcomes following an initiating event. As the number of events increases, the pettier fans out like the branches of a tree. So some of the degree students that have seen this already, but again, remember now it's all about remembering. However, again, in my mind, I cannot picture too much of an ETA question, right? The starting point is referred to as the initiating event. It disrupts normal system operation. The inventory displays the sequence of events involving success and or failures of the system components. So this is what it looks like. Trying to see if I can remember any questions on these things, right? So this is what an ETA chart looks like. If you want, we could analyze it a bit. Let's stop and analyze it a bit. I'm taking off this sum up here, right? So to construct it, it's like a sideways or a horizontal family tree. I could start one here for you if you want to see how easy it is to construct. You start off with the first line, right? The marker is running all over the place, right? So you start off with a line, and then you kind of draw the first branch, right? So it's not that hard, right? So this is another branch. The branch is normally attached from the top. I guess you can attach to the bottom too, as what you see in here. But you can attach them anywhere, right? Typically the branches attached to the top, right? Like that. So every one of that you draw is a branch. They call it a branch of the tree. The top of the chart and really the top line of the chart, like this is a top line, this is a top line, this is a top line. Those lines show what they call success, right? Success that the system worked. If you watch here, success that the system you had for that branch that did work. Each branch represents something like a branch. And if you go back to fire, as what they did here, if we go back to fire, right? Each branch represents like a control for fire. So if you watch it, you have this one is sprinkler system. So this top line here represents that the sprinkler system worked, right? The next one, call to the fire department. The top line represents that you did make a call to the fire department. And if we say maybe we use an extinguisher, in the meantime, this branch it would mean that all of it work, right? So the top branches mean success, that the systems work. The bottom lines, or should we say branches, if you watch here, represents that it did not work. The sprinkler system did not work. The bottom here mean that the call to the fire department did not go through. And here the fire extinguisher, well, nobody really got it in time, right? So the top branches represent success, the bottom branches represents failure, right? So there is some maths involved in this at the degree level, which we wouldn't do here. So I'll just leave the maths out of it. Um, a good way to say that an inventory analysis looks at what they call again like an initiated event, the success that the control measures would work at the top of the chart, and then at the bottom line of the chart, like the failure if those components do not work, right? Those who did the degree, you remember that there is a maths involved in this. There's a formula in each of these lines here. And then you end up with a number, like the number to the end here may end up being 0.99. Still though, like I said, that's a decimal number, but it's a very accurate number. It's a very accurate number at the end, right? I think I'll stop it there because this is level 4 and not the level 6 program. I wouldn't go too much into the formulas and stuff like that. I think that is sufficient for you to kind of describe the model, right? If you're okay with it, we have one more to do, and then that'll wrap up the failure methods anyway, right? Um, this one too, I've never really seen this one. So maybe I could read 2 lines and then, well, 2 slides and then explain it for you. Trying to see how best to explain it, all right? And so let's just have a read of 2 of the slides and I'll break it down for you. FMEA, failure mode effect analysis, right? All right, so I'll read 2 slides, right? So FMEA, failure mode effect analysis. So FMEAs are conducted to improve the safety of equipment by identifying single component equipment and system failure modes, determining the potential effect on the equipment system or plant associated with each individual failure mode, generating recommendation for increasing reliability of the components, equipment, and or system. All right, I think I have to change the marker to get the slide to go, right? So there are basically 5 steps involved in an FMEA process. Break the system into component parts, determine how each component may fail, determine the possible effect of these modes of failure, consider how each failure mode can be detected, assess the consequences of the failure on the system or other components. So if you want, I could just explain it from there, right? So it's kind of right here though, right? So what's like what a failure mode analysis is, they would look at a system and they'll break it down into components and then analyze what the effect of the component failure is on the whole system. So just to make it easy, right? We can use the phone. We could use something in a process plan too, right? But like if you look at your phone, right? So you have your phone, and the phone, of course, is a system, right? But if you're doing an FMEA analysis on this phone, you have to break the phone down into some components, right? So give me a component of the phone. Some of the easy ones, I mean, who?
Screen, battery, or
Screen,
knob.
battery, function, right? There's a lot of things involved in this, right? Like there's something called an accelerometer in your phone. There's a lot of, I don't know if you know that, there's actually transducer, right? In your phone. Not a, but yeah, there's a transmitter, there's the Wi-Fi and whatever feature, right? But there's something called a transducer in your phone. And what that does, right? That causes like when you change your phone like this to that, you see the screen does change. That's what that does, right? So the transducer will actually pick up changes in 3D. Remember, we kind of exist in 3D anyway, right? So um sometimes they call it the X, Y, and Z axes, right? Which is like symbolic of all three directions that your fingers are facing right now. So if you turn your phone, right, you notice that the screen will change in it. So what I'm saying, and we can look at the Wi-Fi. Let's look at something easier than the transducer. Let's look at the Wi-Fi button or something, right? Or the Wi-Fi function, right? So like what they will do if you're doing an FMEA analysis on like a device then, and of course that could be a lot of things uses Wi-Fi. Not too sure what's happening here, right? So what it, like what the FMEA calculation or analysis does, it looks at what if that one feature fails? So that's what they call it there, watch it, component parts. But then they look at what is the effect. So they call that the mode. The mode is the component part, hence it's called failure mode, right? But they look at the mode, like that specific component, and then how it would affect the entire system. So I'm sure you all would agree. I mean, I'm sure you'd agree. If your Wi-Fi feature of your phone isn't working, most of us would probably give away these phones, right? Nobody use phones to call anymore, right? Hardly people use phones. Like, you know, many of you also, I mean, I'm sure we saw it, right? One of the last movies, one of the last Jumanji movies with The Rock. Anybody remember seeing Jumanji 2? Sure you remember it. See if you can recall it to memory. Yeah? Jumanji 2 with The Rock. Yeah? There's a part of that movie, you're not saying anything, right? Where, well, one of the guys that was lost, he was lost like from the 90s, right? So one of the guys was lost in Jumanji from the 90s. And there's a part of the movie where I think when he came back, he was saying he can't wait to see Cindy Crawford. And the people around him said, "Who?" He said Cindy Crawford, because she used to be in a lot of magazines and stuff. And they said, but she's an old lady now. And then something else somebody said about phone, and then he said, the guy who came back from the 90s, he said, like, does phone mean something different in this generation to it did in the 90s? Because everybody was like, I want my phone, can't live without my phone. And I mean, like we who are here, we lived through the 90s, didn't we? Right? We lived through the 80s, I think some of us as well. And yes, phone does mean something different now. Because long ago, I mean, phone would just mean to call. Now phone is everything else, right? Beside in a call. Now, if it's say wanted a phone in the 90s, well, they're going to make a call. Now, if you say you want a phone, you're not really going to make a call, right? So yes, phone does mean something different, right? So what I was saying is that if your Wi-Fi feature is not working, even though the phone could actually still make a call, nobody uses it to make a call. So if that feature fails, then the effect on the system may be that you will have to replace the system, right? Think you understand it a bit, right? And of course, you can break the phone down into different things. Steven mentioned the battery. Of course, if your battery is gone, then even if you have the best phone, the latest, Pro 17, I think, right? If you have the best one out, the battery isn't working, or even if the Wi-Fi is not working, that sort of expensive phone you have doesn't really mean anything, does it? Right? It still is just, but it can still make a call, but we don't use it for that, right? So the battery is not working, but then the effect on the system is that it may be detrimental to your personal use, right? So I can use a phone here for that, but you can think of it as like even your vehicle, right? And God forbid, because we all suffer these things sometimes. Um, the battery dies in the car. God forbid the radiator is overheating. The alternator is not charging your battery, right? And so once one of the failure mode occurs, then like what this analysis does, it considers what is the effect on the whole system, right? And of course, sometimes you could run the system. Like I said, the Wi-Fi could be out on your phone, and your phone is still good. Just it probably wouldn't be good for this generation. Of course, if the battery is gone, the battery is gone. It really mightn't be any use to anything anyway, right? And that's a failure mode effect analysis, right? Break the system into components, determine how each component will fail, determine the possible effects of these failure mode, consider how each mode can be detected, assess the consequences of the failure on the system or other components. Right? I would leave it there because what happened, I have a question, I have an exam question coming up, right? And so, like, I kind of cover, I would ask you to read, there's a couple of slides for you to read out. So you can have a look at that. Some people do it on a table like that. You could read this one out. You could read this one out, right? A what if analysis is like a bow tie and a hazard. We kind of just did it. A what if analysis, if you watch it, right, is actually a hazard. So we kind of did that already. So that's why I wouldn't read that, right? So we can move to this one here, though. This is a famous exam question. And, not to waste too much time, I would like to focus on that before today is finished, right? So, what they normally ask is for you to say what the concept of ALARP means. The first thing you want to kind of do is kind of remember what it stands for. It stands for as low. I don't know if you want to write it down. Um, as low as is reasonably practicable. That's the meaning of ALARP. And this is just a 2-mark question, so maybe you can learn that first line I have there, right? ALARP, as low as is reasonably practicable. Tell me if I'm meant to say it again. Right? ALARP.
You're saying there's a 2-mark question, and I remember when I wrote the level 6 back in 2014,
For you
that
is 1 mark.
question was 40, the max was 30 marks for that.
Yeah, these people crazy, yeah, yeah. For now it's just 2 marks though. Yeah. For now it's just 2 marks. So and remember now, Alicia, you have to remember it now. You have to remember like a definition now, right? So I tried to see if I had a better one, but you see, this one is actually from the HSC website. So let me read it first, right? So risk has been reduced to as low as is reasonably practicable, is about weighing the risk against the sacrifice needed to further reduce it, right? That's a nice definition. I could think of other things to add to it though, but I think I gotta start remembering something somewhere, right? So all of this down here is explanation. This is just explanation. This paragraph is explanation. All of this is explanation, right? Unless if they ask you to explain. But a good way to picture what ALARP is, if you just look at this chart, is that the letters in it then, RP is reasonably practicable. And what that is, what the law requires, the law requires companies to reduce risk then to like a reasonable state, not to zero. See if you're seeing that. The law never said risk must be reduced to zero. It just said reduce risk to as low as is reasonable for you. If you look at here, it says reasonable equals, if you kind of line the X and the Y axis up here, reasonable equates to moderate costs. See if you've seen it. It is not expensive. It is moderate, right? So the idea with reducing risk to as low as is reasonably practicable is that you do balance the level of risk against the sacrifice. Some people say, let me interject some words, that the sacrifice here is in terms of costs, time, and effort to reduce the risk. Costs, time, and effort to reduce the risk. What does that mean? It means you are going to spend money to reduce your risk as a company. You're going to spend time, you're going to make effort, you're going to make an effort to reduce the risk, but it's not going to be too expensive. If you want, I could give you an example, right? So risk has been reduced to as low as is reasonably practicable. A good way of thinking about this, if not a good way, a way of thinking about it is, like you have, somebody to buy something for, right? I've used the same examples at the certificate level, given the fact that Friday was Valentine's. And of course, I had two students, it was their birthday on Friday, a guy called Terrence, and I had a student, Shanna, I think her birthday was actually Friday, right? So yeah, people buy gifts every day and whatever. Today's Sunday, bound to be somebody's birthday as well today. But what I'm saying is that if it was a special occasion now, and you had to buy something for
So,
somebody, yeah,
sorry to interject. Yep. Yeah. In your previous statements, you pick reasonably practicable to being a moderate cost, right?
yeah, yeah,
While I agree with that, um, I think also reasonably practicable also mean following industry standard because you can have one board of managers saying that, let me just use an example, we don't need level 2 uh, NOMEX, we can use level 1, while
yeah,
the industry uses level 2.
yeah,
Now, how do they justify using level 1 as being reasonably practicable in the eyes of the law? Because remember, even though the use itself is practicable, when it goes to court, they have to justify it.
right. Okay, well, I wouldn't be able to say what a company does, but like I said, like in terms of like as low as is reasonably practicable, what I was trying to say, well, I'm not too sure if they will take industrial practices. I understand that in terms of everyday life, companies may judge it on industrial practices, but like by definition, then like the three quantifying criteria is cost, time, and effort. What I was saying there is if something you had to purchase for somebody could be PPE or maybe some gift, right? What as low as is reasonably practicable means that you are digging deep in your pocket to buy that gift, right? But you are not putting yourself out there. You're not gonna go broken buying that gift, right? So the law never said spend all your money to reduce the risk. It just said go as low as you could go to reduce the risk. Think you understand that a bit? You're not going to, if your company has
Yeah,
$100,000, you're not going to spend all of that to reduce the risk, but you're going
I
to
got
go
to
as low as you could to reduce the risk based on your cost to the company, right? I mean, a bit, see if we can get back a bit. So you could use industrial standards. If something is, like I said, a particular type of Nomex coverall, if that is the industrial standard, well, then that is what will have to be purchased, right? In terms of the phrase industrial standard itself, though, I don't know if that will work as an example. I think that's more of an example than a definition. Nothing is wrong with it, right? Industrial standards can be used to judge what is like acceptable. And then it's up to the company now to purchase that particular type of equipment or PPE. However, though, I think by law, what if the company doesn't really have the money to purchase that type of coverall, right? In terms of the level 1 and level 2, right? So that's what they say. It's about weighing up the risk. Like, is the risk reduced based on what you are going to spend, right? So some people draw it like a seesaw where risk is on one side, right? And if something is that expensive in terms of cost, well, what you are buying, did it reduce the risk? And if the risk had gone down a bit, kind of like out of the red for those of us who know the risk matrix, but then that is what may be acceptable for your company. The law is not saying buy a particular thing. The law is saying balance the risk, right, against the cost, time, and effort, which is sacrifice that will be needed to reduce the risk. Think you understand it a bit? This is kind of open then. It is not absolute. It didn't say this must be done. They left it to the discretion of the companies to decide what is reasonable for them, not what is reasonable for a neighboring company. What your neighbor does then might not be reasonable for you. So the law left it to be a personal thing where even industrial standards may just be a guide. But if your company is in the red and they could get a level of NOMEX that does reduce the risk at a cheaper cost, that is what they will do, right? What do you think about that? If it ever comes up in court, it's up to the judge to decide if what was provided was fair, if what was provided was reasonable, and if they had reduced the risk to as low as is reasonably practicable. Yeah. See if we could take down cost, time, and effort. At some of the levels, we ask students why. Why did the law do that? Why didn't the law just say spend all the money? Anybody can answer that question? Why didn't the law just say spend the money and buy the expensive thing? Notice the law did not say that. Look at here, reasonable is here. This is how you graph it out, right? Risk has been reduced as low as is reasonably practical, but does not mean an expensive control. It just means a control that is reasonable to the pocket of the company, right? So the question is why? I mean, not why. I mean, this is not an exam question. I'm asking you, like, why do you think the law said that? Why do you think the law left it open to the company to judge what is practicable or reasonably practicable? Why do you think the law didn't just say spend all the money and you must reduce risk to zero? Why do you think the law did it like that?
To be fair,
Yeah, to be fair to the companies too, right? In other words, then, what may be good for Atlantic LNG, and that is the industry standard, may not be for a small contractor, right? The law left it to be fair to the employer. If you could have a brand of that Numex coverall that does give the protection, but it's not the same one Atlantic is using or whatever equipment, right? To that company, it is fair. The law left it like that. I didn't make this chart. That's what I'm trying to tell you. I'm just trying to explain to you what ALARP is. I didn't construct this chart. This is just a chart we got from off, the source material, right? So ALARP is seen to be a moderate cost and not an expensive cost, right? I do suppose if a company have the money, then to them it is seen to be reasonably practical, but to spend the excess money and to get the expensive stuff, right? But in a way, the law is not that of a taskmaster now. It's just saying do what is fair to your company, right? Let's bridge into our past paper. We almost finished for today. So then on Wednesday, we'll be moving to 1.4, the part on documented evidence, right? I'm sure we'll finish that as well. So I have a past paper. Oh, no, we have all of this to do still on Wednesday, modeling calculations and the documented evidence. The good thing about this is that it's easy, right? So it looks as if I'll have to send you another PowerPoint again for chapter 2, right? It's only 4 chapters, by the way, in the book. Chapter 4 is very simple. All right, there's a past paper somewhere here, but there's actually one that I had open up to, right? So um see if we could have a look at this one. We have concepts and commissioning process plan project phases. Well, remember this question, right? Where risk management applies. Identify 4 additional project phases where risk management applies. Anybody could identify those 4 other stages? I told you to learn it on Wednesday, but I know you probably haven't learned it yet. They have what do you have? Concept and commissioning. So what is 2 other phases? I'll give you a clue. One of them sounds like commissioning. It actually have the word commissioning in it as well. Project phases.
Decommissioning.
Decommissioning. Very good, right? Decommissioning. Modification is another one, right? It's in this PowerPoint. I didn't mention it if you're here Wednesday. Again, like I said, the video is there, but your folks,
Project
right?
planning.
Say it again.
Project planning.
Project planning, right? Yeah. I was telling you all, folks, you all just pick up the PowerPoint and start to learn it now, right? I'm kind of starting to talk to all of my classes. I'm kind of going against nature right now, which is everybody kind of loves the video, but in an hour and a half time, you could actually learn that you could read this PowerPoint 10 times, right? And you kind of get the information instead of waiting to hear it on a video, right? We all learn differently, it's true, but I still find the PowerPoint is a quick way to learn on the spot and to move on, right? When I came to this study, I did tell it was a past paper. Apparently, it was right here. The different stages of a project. What you said, concept, planning, and commissioning are two of the phases. They wanted four other phases. I said decommissioning, I said modification. It could go to turnover and startup. But this was a slide to learn then because of that past paper, right? Let's go back to it. Okay, so that's it. No, look at here, right? Okay, so which one I passed it then? It had another question. Okay, this one, right? So Part B outline the concept of as low as is reasonably practicable within risk management. How much marks? 2 marks. How much lines that may take? That may take about 4 lines if you want, with a brief explanation, right? So you could read the slide I had one day. I mean, you could say, risk is balanced or weighed up against the sacrifice in terms of cost, time, and effort to reduce it, and you can make up an example. You can say like maybe to ventilate a tank that is high risk, the company would have to spend the money to do the ventilation. They may have to hire a gas, like a contractor to do gas monitoring. They'll have to spend the money then based on the fact the risk is high. So cost, time, and effort, they'd have to make the effort. You can make up an example on it, right? Part C outline how a quantitative risk assessment differs from a qualitative risk assessment. 2 marks. You have to find 2 ways, and each of the answers may be about 3 to 4 lines long. This question, it requires 2 answers, like part A and part B, right? Part A and part B. And each one, you kind of give it like a 3 lines, 4 lines kind of depth anyway, right? The trick is, remember, you have 2 hours, so you have to kind of have it right. Anyone could say a difference off the top of the head? If you want, I could give you one. I'll try to give you a hard one. So I would say a quantitative risk assessment is more objective than a qualitative risk assessment. That's one difference. Could you think of a simpler difference? Quantitative risk assessment uses what?
Numbers.
Numbers, right? And you could say numbers like like numbers like binary numbers, zeros and ones, like 0.899. And then a qualitative risk assessment uses what? Anybody help him? Qualitative uses what? If quantitative uses numbers,
Words.
qualitative words such as high, medium, or low, right? Now, here what I want you all to do, right? I was going to show you another one enough, but one is enough, right? Here what I want you all to do. I want you all to do one of these questions for me. Maybe this one, as we on this one. It don't make sense show you another one and blindside you too much, right? I want you all to write it. I think I'd mentioned that to you all and sort of submit it to me. Now, I know some of you all may have done it. I know some of you may have sent some assignments in, right? Kind of conscious of something on WhatsApp. Not much of it was email. And actually, WhatsApp, I don't really look at homework there. But as I said that now, I remember, saw somebody handwrite something and send it in, right? So if you can do that, if you could have handwritten it, and that would give you the habit of writing, but I would have preferred that you email it in, right? If you all see my phone on a Saturday or a work day, in fact, now it looks like a Christmas tree, right? Sometimes by Wednesday, I am still sorting out Saturday messages. Yes, when you message me on a Saturday because I'm teaching, I still, by a Wednesday, I'm still, because it's not all I do then, right? I might do other things. So, like, yeah, I mean, definitely, like, look at it. All of these are unread messages. So in the work day, when I get some time and you can go down, and the more I really saw that, the more I go down is the more you're gonna see it. The more I go down is the more you're gonna see it, right? So like something by Wednesday, I'm still responding to messages, right? That's why WhatsApp is not really a good way to send me assignments, right? I am actually scrolling more down and since I talked to you all, how much messages it have, they're still going down, right? So yeah, so WhatsApp is not, if you could write it and probably scan it and send it, as long as I'm talking to you all, I'm still scrolling and it still have those unread messages there. So it takes me till about Wednesday. Cause like it's like when I hit the office and I have other things to do, just when I get a couple minutes, I try to respond to some of them, right? Sometimes it's just people saying stuff to the group and whatever have you, right? So there's no way to tell which is more important than the other one then. Somebody said here they emailed me a resume for work, right? So, so if you want your assignment kind of corrected, just showing it now, WhatsApp is not the place to send it, right? You need to write it and you need to send it for me. Now, we need to do that because we need to practice your writing skills a bit, right? This exam is a bit strange, I told you all, right? And um just now, huh? And there's no really other way to get it. You kind of have to start writing. And if you write it and you send it for me via email, probably scan it or something and send it in, I'll give you a feedback on it, right? So I think you all should do that. That's the one downside I was telling you also we started the class. I have mentioned to you all, it's a serious concern for me where like I can't see what you're doing now, right? I know some of y'all working, you have the cameras off and stuff too, right? But I was telling you all, it's a good idea for us to meet on a Sunday. If you don't want to meet on Sunday evening, I have no problem with that, right? We have a building down in Riverside Drive. San Fernando can send you the direction state and stuff. We could have our same class, right? One of these classes we are having, we could have, for those who remember having classes there before the pandemic, right? We could have like maybe a good 2 hour session, take a break, like 9 to 10, half 8, maybe I would have preferred start earlier, half 8, half 9, half 10, take a break, come back and look at some past papers and then wrap up by 12 o'clock. Nice social interaction, right? Whatever have you. If you all do that, I'll sponsor your lunch. Whatever you all want to eat, we'll sponsor your lunch and a drink. But that would kind of give me the option now. And it didn't have to be 2 hours of teaching, right? I could do 1 hour. But what I did, I told is I could give you a question like this and time, you get 10 minutes to do it. When we say time up, you bring it up and then we see how you're going and we do another one and we do another one. Now, take it from me, it will never be perfect. Some of you would experience the pains of having to write under 10 minutes, but that will prepare you for writing under 2 hours because the day for the exam you have 2 hours to do 11 questions anyway, right? Tell me what you all think. I think we need to get a move on it and stop talking about it because time is kind of running down at the same time, right? Time is kind of running out at the same time, right? So let me know. We can probably plan one for March, probably plan one for April, right? That would be our Sunday then, right? And we could plan it well so that you plan it well with your families and stuff as well at the same time. Those of us who know us, like I said, like Alicia here, Sunday was always classes, right? Year come, year go, for more than 10 years, we had classes on a Sunday morning live. The strange thing was, you remember it had a time, remember it had a time it had a storm coming to Trinidad? That was the last storm we had in Trinidad, right? 2020, we didn't have any storms. They had like a tropical thing coming to Trinidad. I had class that morning. And you know what's even surprising? You know what's surprising? All the students came out. That was the most surprising thing to me. To tell you how people had like it wasn't during the pandemic, so it was like probably 2019, right? It was everybody come out to class. The government they had a red warning, it was red, like the warning level was red. No one's supposed to go anyway. I know what all the students came out to class.
So, just recommendation, if it's possible for us to have it before the month, well, before next month, I should say, because remember I told you I'll be fasting
Yeah. It's just only one more, a couple of Sundays remaining, isn't it? Remember
I know, I
today's
know,
week.
I know. But
Yeah, yeah,
if everyone agree and it could be done before the month is over, I would appreciate it. If not, well, I'll see what arrangement I
yeah,
can make when that
yeah.
time reach.
We just have today's the no, it only have one more Sunday in this month, which is next week Sunday. So I don't know if the class will be able to respond in that fast time. When is Eid?
Ramadan actually starts, I think, the 1st of March. So it may be could be like about the 29th, 30th of March.
It will be the 31st of March.
31st of March.
Yeah.
Okay.
Yeah, they put the holiday for that time. But yeah, well,
As well
we just
as
observe it for about
spiritual
29 days.
baptism on the Sunday.
On the Monday. Wow,
Sunday and Monday
okay.
will be the most holidays.
Okay, okay. All right. Well, I could recommend a day in March itself, to be honest, right? Next week Sunday is a weekend before one of my NEBOSS audits, so I don't want to put it on that Sunday. I prefer have the audit run out, which is next week. No, the other week, the 25th, is a NEBOSS audit I have, right? So I prefer that kind of get behind me, and then I could be a bit freer. Mentally, I'll be freer in the month of March to do a Sunday, right? If we had put that thought in it more, today could have been a good day. Today could have been a good day to come out, right? But let's plan it, let's say around the middle of March, maybe the 9th or the 16th of March. 16th is a month away. So that you make prep, like for your family. Because remember, since the pandemic, a lot of people are not really going to physical classes, right? But because this is a physical exam, I think it's a good idea to come out on those days anyway. And they get one thing done. I wouldn't take your whole Sunday. I'll probably have you go until about 12 o'clock. Um, half 11, I think 12 until it's time to wrap up. So at least you get back the rest of your Sunday for yourself. If anyone I know, I don't think anybody's in a different country here. I know I have some students from Guyana, but I don't think I have anybody from Guyana here, right? I know Devon, but Devon is a Trinidadian, right? Just say he's in Guyana, so he may not be able to attend, right? That sort of session, right? But that's just how it is. I mean, it's one person compared to the rest of us anyway, right? Folks, let me get the rule, and that's a bit for today. I'll sort of lazy it a little bit on Wednesday. I don't have to email you another PowerPoint for Wednesday because I think we'll finish off this thing here. But still, can you all kind of get this question done tomorrow, Tuesday? Write it out, right? Don't type. Practice back the writing. Practice back the writing. If possible, I know it's tougher. Try to time yourself. Give yourself 15 minutes max to exactly get this question done. 15 minutes max. Also remember, the one lines are not going to give you a mark. Part B and Part C requires at least 2 lines, 3 lines each for one of the answers. If you just put there a quantitative risk assessment uses numbers, full stop, you wouldn't get any marks. You'd have to talk about it more. You have to talk about binary logic. You have to talk about numbers, zeros and ones. You have to add some lines then. So you could research it and do it well because remember these are past papers now. And the good thing about past papers is that they tend to repeat anyway, right? All right. Akash.
Yeah, President, I put it in the chat. You may have missed it, but I really like your idea of the face to face. That's really great initiative. So thank you for that.
Yeah.
Also, I may have missed it, but when are we due to do exams for this course?
This course is what is called an on-demand course. There is no set date. When we are nearing completion, I have to apply to NEBOSS to host the exam, right? So
Okay.
I think there was a schedule you all had. It was somewhere in April that we were kind of tentative, to finish off the course, right? So we'll work it out, but it's a tentative schedule. But there's no set day for oil and gas, right? Certificate have a set day, you all know that. That's the first Wednesday of every month. Process have a set day, that's the third Wednesday of every month. Diplomas have set day, but this course is called a on-demand. People around the world run it, and when we finish or finish in, like you see, 2 weeks that they're going to finish, you apply to NEBOSS to host the exam. And that's how it works for this, like with these courses, right? Yeah.
Okay.
All
Thank
right,
you.
Shanil, Ryan.
I'm here.
Thanks very much. Rachel Thompson. Naveen, I know Rachel is here. Naveen is here. Jessica Alfred.
Present.
Thanks very much.
Yeah, Shadi, sir.
Nigel. Okay, yes, Rachel, right? Nigel Smart. Heard from Nigel in discuss, right? Crystal Thomas. Alicia is here.
Yeah.
Thanks, Crystal. Alicia, of course, is here, right? Rian Gilbert. Christopher Goben. Alicia
Yes, is
Kaya.
it just
Go ahead. Yes,
Present.
that was
is it
Christopher.
just one? Yeah, it was Christopher. Is it just one exam we have for the entire course?
Yeah, just one exam, 11 questions. Pass mark is 45. No
Thanks.
project. The main thing though is
45%?
speed. No, 45 marks.
And how many marks in total the exam have?
I'm 100. 100.
Okay, thanks.
Right? Yeah. Because somebody passed it, but I email you on. I think I email you on the 2013 paper. I have it open here now, but I didn't get time to share it with you, all right? Because the question was on the PowerPoint. Yeah, the hardest thing in exam, other than studying, is speed to write with a pen, right? Alim is not here. I don't think so. Stephen is here. Raven told me he wouldn't be here. Devon Lewis doesn't seem to be here, right? Folks, enjoy the rest of your Sunday. You know, when you get some time, take a break, of course, now. Regroup a bit and you could actually look back at something maybe a little bit later on today, right? All the best for the rest of the day, folks. I actually have another class to go to, so I'll get to that now, right? All the best, everyone. Bye.